Okay, so for today, we're going to discuss the week 8 of logic circuits and switching theory, wherein we're going to discuss the design of combinational circuits too. So last week, or in the previous week, week 7, we have discussed the design of combinational circuits 1. So for today, we're going to continue that and find some application of our logic circuits. So our learning outcomes for this lesson is first to explain the function of decoders, encoders, and multiplexers. Second is design and build decoders, encoders, and multiplexers. And third, use different design schemes to build standard components. So these are the module that you can use or as a reference para po malaman nyo what is the proper design and proper table to use para po magkaroon kayo ng decoder, encoder, and multiplexer. So parang i-guide niya kayo into building one of them. So let's define decoder. So si decoder is a combinational circuit that converts binary information from n input lines or any number of input lines to a maximum of 2 raised to n unique output lines. So kung ilan man yung maging input lines natin, so let's say that is 3, that is your 3 input lines, then ang magiging output lines natin would be 2 raised to 3. So dapat ganun yun because that is the conversion of binary information. So when we say decoder, that is an N to M or N is to M line decoder that generates 2 raised to N or fewer minterms of N input variables. Application example of decoder is a binary to octal conversion. N-bit decoders can provide M outputs. It may be implemented with NAND gates, which is more economical, but will produce the complemented form. So vis-a-vis implementation using AND gates. A decoder with an enabled input can function as the multiplexer, which is a circuit that receives information from a single line and directs it to one of the 2n or 2 raised to n possible output lines. So those are the information that you need to understand when it comes to decoders. So we have here an example of 3:8 line decoder. Then meron din tayong 2:4 line decoder. So as you can see, may input tayo here ng 3 inputs, then may output tayo na 8. No, 8 decoders. So we used here 3 input AND gates and inverters. So as you can see there, the output of each, the input of X, Y, and Z, meron siyang co-equivalent na output of X prime, Y prime, Z prime, and so on and so forth. So dapat lang tama yung magiging connection natin here in the decoder. So next naman is yung 2:4 line decoder, wherein yung ating magiging, yung input natin here is the A, B, and E. Then ang ating magiging output is yung 4 from D0, D1, D2, and D3. So that is the enabled input. Ay, ito pala. Sorry. So, itong, kung itatanong nyo, ito pong ating circuit or combinational circuit here. Sabi po is 2:4. So, that is 2:4. No, A and B lang naman talaga input natin dyan. Kaya siya nagkaroon ng isa dito. Ito yung enable natin na input. No? So, kasama po siya sa magiging input. Pero again, 2:4 pa rin yung ating scheme wherein yung ating output is 2 raised to n number of inputs. Encoders. So by definition, encoders is a digital circuit that performs the inverse operation of a decoder. So it has 2 raised to n or fewer input lines and n output lines. So kabaligtaran naman po siya. The output lines generate the binary code corresponding to the input value. So we have here what we call the priority encoder. So wherein this is a circuit that gives precedence to the input that has the highest priority. So this is an example of a 4-input priority encoder wherein meron tayong 4 na input. So that is 2 raised to n. then yung N natin yung magiging output natin. So meron tayong what we call the V or yung ating priority encoder that is also one of the outputs of our circuit. Okay? So multiplexer. Multiplexer is one of the most commonly used combinational circuit. It chooses an output from among several possible inputs based on the value of the select signal. So familiarly called MUX or MUX. So yes, that is true. No? Yung multiplexer natin is MUX yan minsan for shortcut na multiplexer. Pag demultiplexer naman, demux naman siya or MUX. So yun yung shortcut niya. So ito yung symbol natin for a multiplexer. So we have here the truth table for that wherein our S, D1, and D0 or D0 is meron siyang output na Y. So you can refer to this truth table para po maintindihan natin yung ating symbol for multiplexer. So multiplexer natin can be built from SOP or tri-state buffers. Wider multiplexers can be also built with smaller multiplexers. So we have here a multiplexer with logic gates. So pwede naman siyang in a form of logic gates. Hindi naman necessarily na gagamitin natin yung mismong idea ng ating or symbol ng multiplexer. You can use logic gates with that wherein ang ating magiging output must be Y from all the input S and D. Then, ganun din, pag gumamit tayo ng tri-state buffers, okay, or yung gagamit tayo ng buffer amplifier, no? So, with multiplexers. So, meron tayo dyang S1 bar, S0 bar, or S1 bar, S0, then meron siyang co-equivalent na input D0, then magiging output natin is Y. And lastly is we can use the original form of the multiplexer symbol wherein meron tayong 4:1 multiplexer that is built with 2:1 multiplexer. Okay, so that is the end of our lesson for combinational circuits 2 for the design of schematics.